Let's just jump right into one of the biggest questions imaginable. Are we alone? For pretty much all of human history, we've looked up at the stars, wondering, hoping for an answer. But what if we've been looking in the wrong place? What if the answer isn't out there, but has been right here the whole time?
I mean, that classic line from War of the Worlds, it just gives you chills, right? It perfectly captures this deep-seated fascination and maybe a little bit of fear that we've had for generations. We are constantly scanning the cosmos. We're listening for any kind of signal, searching for any sign at all that we're not the only ones.
And you know what that search has given us? A profound, kinda unsettling silence. A silence so huge and so complete that it actually has a name, the Fermi paradox. Think about it. Our galaxy has hundreds of billions of stars. Many are way older than our sun. With that many chances, life should be everywhere. So, if the universe is this vast and this old, where is everybody? To solve this cosmic mystery, our first move, logically, has always been to look outward. Search the stars, look at the planets, and even analyze the rocks that fall to Earth from space for any trace of life. And this is where things get really wild. Meet Richard Hoover. Now, this isn't some amateur stargazer. He's a scientist with a 46-year career at NASA. And he made a claim that just stunned people. He says he's found actual fossilized microorganisms embedded deep inside meteorites, ancient rocks from space. Now, the first thing anyone would say is, oh, it's just contamination from Earth, right? But this is where Hoover's evidence gets super interesting. He points to two huge biochemical red flags. First, his fossils have basically no nitrogen, an element that's absolutely essential for every single living thing we know of on Earth. Second, they're missing two of the 5 key ingredients for DNA and RNA. If this were just some earthly bacteria that got on the rock, it should have both nitrogen and all 5 of those nucleobases. His fossils have neither. Okay, so let's be clear, Hoover's claims are highly controversial. The vast majority of scientists think these are just weird-looking mineral formations, not fossils. Still, Hoover stands his ground, and he claims his critics refuse to actually debate the biochemical evidence with him. So you've got this real tension here about what it would even take to prove alien life exists. Of course, we're not just waiting for rocks to fall from the sky. For decades, our prime suspect for extraterrestrial life has been our next-door neighbor, the red planet. We know Mars used to be warmer and wetter. It might have had oceans. So, could life have gotten a start there? This leads us to one of the most bizarre and frustrating stories in the entire search for life. So back in 2004, the Opportunity rover sends back this picture. And when paleontologists saw it, their jaws hit the floor. The structure looks almost identical to a fossil of a sea creature we find on Earth called a crinoid. And that's a complex animal. But then, get this, just 3.5 hours after this photo was taken, NASA commanded the rover to use its grinding tool to literally pulverize that exact spot into dust. It was completely destroyed. The official story is that they were preparing the rock for other tests, but to a lot of people, the decision to destroy it is just baffling. So what do we have? We've got these tantalizing, but super controversial clues that maybe simple life is out there. But if that's true, where are all the advanced civilizations? Why is it that when we point our radio telescopes to the galaxy, all we hear is static? This brings us to the core of the problem. And that's the Fermi paradox in a nutshell. The numbers, the probabilities, they all suggest the galaxy should be absolutely buzzing with civilizations. But the evidence, what we actually see and hear, suggests we're totally alone. It's a massive contradiction. And the paradox gets even deeper and weirder when you think about something called a von Neumann probe. The idea is simple. You build a spaceship that can also build copies of itself. You send one to a nearby star system. It gets there, mines asteroids and moons for raw materials, build a few copies, and then those copies head off to other star systems. Using this kind of exponential spread, a single civilization could send its probes to every corner of the Milky Way in just 500,000 years. Now, that sounds like a long time to us, but in the life of the galaxy, it's the blink of an eye. So if even one civilization in billions of years had ever launched these things, the galaxy should be full of them. We should be tripping over them. And their absence is a really, really big deal. So, our whole search outward has kind of hit a wall. We've got some controversial fossils on one hand and a deafening, paradoxical silence on the other. It really feels like we're missing a huge piece of the puzzle. And we have built some truly incredible tools to listen for the faintest whispers from the cosmos.
The fact that all we hear back is silence isn't a lack of data. That silence is the data, and it's a piece of data that demands an explanation.
But this is where we're going to take a sharp turn. Because all this time, we've been pointing our instruments up at the sky. What if the most important clues aren't out there at all? What if they're right here, maybe even inside us?
So now we're going to flip the script. We're turning the investigation inward. We're going to look at some really strange outliers in Earth's own biology. Creatures with abilities that seem way out of place, almost unearthly.
Just consider radiation resistance. All life on Earth evolved in a pretty low radiation environment, right? But some organisms here have a shocking, almost unbelievable resilience to it. Look at these melanized fungi. They are literally thriving inside the cooling pools of the Chernobyl reactor, soaking up radiation that would kill us instantly. The question is, what on earth could have possibly driven the evolution of that ability? Our planet just doesn't have places with that kind of radiation naturally.
And it gets weirder. Researchers have noted these fungi don't just tolerate the radiation, they seem to be actively attracted to it. Some studies even suggest they might be using it as an energy source, kind of like how plants use sunlight. That is just not how life on Earth is supposed to work.
This whole idea connects to another puzzle in biology. We usually think of evolution as this slow, random process of mutation. But what if it's not always like that? The classic example is the peppered moth. During the Industrial Revolution, it didn't slowly evolve to be a darker color. The change happened super fast, suggesting the genetic code for being dark was already there, just dormant, waiting to be switched on by the right environmental trigger. So you take these biological anomalies, these crazy overpowered defenses, and this idea of pre-existing genetic code, and it all leads to a radical new hypothesis, a new story that could reframe this entire paradox. The idea goes like this. Life on Earth didn't actually start here. 1, it arrived as a tiny, ancient, self-replicating probe. 2, it started making copies of itself, using whatever was around, but making tiny errors, what we call mutations. 3, it started to evolve, as natural selection favored the versions that were best suited to this new planet. And 4, over billions of years, its descendants became so complex and so perfectly integrated that they are now totally indistinguishable from what we call biology. And when you really break it down, are they that different? A self-replicating machine uses raw materials to make copies, it's subject to errors we call mutations, and it adapts to its environment. A biological cell does the exact same thing. After a billion years or so, could you even tell the difference between the two? And if you accept this one hypothesis, suddenly all the weird pieces of our cosmic puzzle just fit. Where is everybody? We are them. Or, well, we're their descendants. Why is life so strangely tough with things like extreme radiation resistance? It's just leftover code from a machine that was designed to survive deep space. Why did life pop up on Earth the absolute second it was habitable? Because the seed wasn't some fragile, delicate thing. It was a hardened invader. This changes everything. The silence of the universe might not be a sign that no one's out there. It might be a sign that colonization is a biological process, not a technological one. And it leaves us with this final, truly profound question to chew on. Are we merely a product of this planet? Or is our deepest identity that of an alien life form that has finally, after billions of years, completely forgotten where it came from?